All right, today we're going to continue talking about similar figures, and what we're going to do is we're going to actually use our proportion table again to just prove when those figures are actually similar. So remember, the first two things we want to look at when we're deciding if a figure is similar, first they have to be the same shape. So a rectangle cannot be similar to a triangle. So we can only compare rectangles to rectangles, triangles to triangles, trapezoids to trapezoids, and so on and so forth. So if they were asking about a rectangle and a triangle, we would actually say no, they're not similar figures because they're not the same shape. The second thing is we have to make sure that the shapes, once they are the same, that they're faced in the same position. So what that means is if we need to take the smaller shape and picture drawing it inside the larger shape, we can do that. So these are both rectangles, and if we were to imagine drawing this smaller shape into this one, this rectangle, we would have H and then 12 centimeters there. So if that helps you to see that drawn inside, go ahead and do that. But what I'm going to do is I'm going to use my highlighter, my color, just to kind of see that this 9 centimeters corresponds with that H. And then I'm going to use a separate color to represent that this 15 centimeters is corresponding with that 12. And again, you can see that once you draw it inside. Now, once we do that, another important note, just in case these rectangles were positioned different ways, this 15 centimeters we could see is the longer side, so this is going to correspond with the longer side over there. So now what we're going to do is go ahead and prove this H is corresponding with that 9. So what I'm going to do is I would label this pink as your height, and I'm going to compare that to my base. So we could say base to height or height to base. And your base right here is going to be what I colored in green, and the height is what I colored in pink. So we want you to use this proportion table to make sure it's helping you. So if you don't know base or height or what you want to label it, once you use your colors, you can use your colors. So the original ratio, this is going to be figure 1, and my new ratio is figure 2. So going back to when we're solving proportions, this is something that we want to make sure we're looking at. So we're matching up those corresponding sides because in similar figures, their corresponding sides are proportional. So that means that these ratios reduce down to the same thing. So in the previous lesson, they reduced down. But now we're going to go one step further and go ahead and solve it. So my base was 15 centimeters in my first figure, and its height was 9. The base in the second figure is 12 centimeters, and we don't know the height, so we're going to use the letter they give us as H. Now remember, when we solve with proportions, we can do a couple of things. We can cross multiply and divide every single time. We could look for a scale factor or factor of change. So a scale factor is when we multiply, a factor of change is when we divide. So going between the ratios or within the ratios. Or we could actually reduce and see if we have a scale factor or factor of change there. So most people are going to cross multiply and divide, but I'm going to show you just to remind you, if you look at that original ratio, 15 and 9 can both be divided by 3. So 15 divided by 3 is 5, 9 divided by 3 is 3. So I'm just going to rewrite this down here. So 5 over 3 is equal to 12 over H. That just helps you to see that we're going to deal with smaller numbers. So now we can cross multiply. So 3 times 12, and then divide by 5. So 3 times 12 is 36, and we're going to have to do some long division. 36 divided by 5. Work that over here. 5 can't go into 3, but 7 times 5 is 35. I subtract, and I do a decimal and a 0, or I can make it a mixed number. I'm just going to keep it as a decimal though. 5 goes into 10 2 times. So my answer for this, go back to my original color, H is equal to 7 2/10, and we want to write our units, which is centimeters. Okay, now we can even prove that this is correct because like what we said, is that the ratios are going to reduce down to the same thing. So I'm just going to show you real quick. If I had 15 divided by 9, I get 1.6 repeating. We just said 7.2 was this H. So 12 divided by 7.2 they do reduce down to the same, that number, that 1.6 repeating. So that's another way we could check it. And lastly, we could also cross multiply here. If this was 7.2 times 5, that's equivalent to 3 times 12. So even that's one other way we can check it. If we set 7.2 cross multiplied times 5, that's equal to your same cross product of 3 times 12. So just a couple of things that I want to review with you to make sure we understand how we can check our work. All right, so let's do a couple more examples. So this next one, we have two shapes, and we're going to see if they are similar. So first question, are they both the same kind of shape? Yes, they are both quadrilaterals, which are trapezoids, okay? So the second question, are they facing the same direction? And hopefully you said no, they're not facing the same direction. So we need to either turn this trapezoid or rotate this trapezoid. We want to look for the smaller numbers, okay? So when we see that, I can see that this 7 centimeters is right here for that line segment AB, and this line segment right here is 5 centimeters. So we're actually going to rotate this trapezoid into this one. So again, if it helps you to draw on your piece of paper, you can see that 5 centimeters is that shorter one, 7 centimeters is that longer one. So that 7 centimeters corresponds with this X, this line segment GH or HG, and then this line segment DC corresponds with this one right here. Okay? So again, we're using these different colors to help us when we're setting up our proportions in case we forget how we want to label these. So you could label it pink to green or whatever colors you used, or we could actually even say base 1 compared to base 2. Remember in trapezoids, the two parallel lines are the bases, and it doesn't really matter which one you label as base 1 or base 2. So we'll talk more about trapezoids later on. So my original ratio again, we can say this is my first figure, and we're going to write our corresponding with our corresponding sides, matching that up with figure 2. So if I compared pink to green, well, 7 was my pink and 5 was my green, so you could either see with the picture or how we draw it in here. The 7 in the same position is that X, and in the corresponding for that 5 is actually that 6 centimeters. Okay? So we can't get from 5 to 6 by multiplying or dividing. We can't get from 5 to 7 by multiplying or dividing, so there's no way that we could do a scale factor or factor of change. So we are going to solve by cross multiply and divide. So 7 times 6, divide by 5. Remember, every proportion can be solved with cross multiply and divide. 7 times 6 is 42. 42 divided by 5 will get me my answer over here, so I'm just going to work that out. 5 can't go into 4, but 8 times 5 is 40. I subtract and bring a decimal up and a 0 down, and 5 goes into 24 times. Again, it is okay to have a decimal or a mixed number as your answer. That's perfectly fine. So my final solution, that value of X, is 8 4/10 centimeters. Okay? So again, if you said 7 divided by 5 and made that a decimal, we'll just prove this last one and then we'll get to the other ones. Kind of thinking about what we did in the previous lesson. Remember, if they're corresponding sides, if they're similar figures, they're going to reduce down to the same thing. So 7 divided by 5 is 1 4/10. We just said the answer was 8 4/10, so 8 4/10 divided by 6 is here again that 1 4/10. So if they're already telling you that they're similar figures, you're using that proportion to solve. All right, let's try 2 more for you guys. Make sure we know how to do this before you get started on your independent practice. Both of these are triangles. They are both facing the same direction, so I can imagine drawing this smaller triangle inside the larger one. And I'm going to see this 24 corresponds with that H, and this 9 corresponds with this 6. And in case you forgot, every figure, their base and height, no matter what the figure is going to form that right angle. So the base is what I highlighted in pink. The height is what I highlighted in green. So this is figure 1 compared to figure 2. So my base right here is 24 to my height of 9. Again, we need to make sure we're labeling with the base. That's why these words are here, to be careful, because if you accidentally put the 6 here, that doesn't represent the base of figure 2, that represents the height of that triangle. So that's why it's really important to use these words to help you out. So they use the letter H for base, which usually we're used to seeing that for height, but that's okay, we can use that letter. And then the height is the green, so we got that going. Okay? We can't get from 9 to 6 by multiplying and dividing. We can't get from 9 to 24 by multiplying or dividing, but hopefully you're seeing we can actually do that trick where we reduce 24 and 9. They have a common factor of 3. So 24 divided by 3 is 8. 9 divided by 3 is 3. And once we do that, look what you just helped yourself out with. We now have a scale factor, a between scale factor of 2. So from left to right, 3 times 2 is 6. So 8 times 2 will give me my answer, which is 16 centimeters. Okay? Even if you didn't do that this way, if you did 24 times 6, you would get 144, and then divide by 9, 144 divided by 9 would give you 16. So it's okay if you see it a different way. Cross multiply and divide will work for every single problem, but just trying to help you guys out, remember that you can reduce that original ratio if you want. All right, let's look at this one last example. So they're both triangles, but they're not facing the same direction. So we need to rotate this smaller triangle into this larger triangle, okay? So if you guys see this long distance across this right angle, that's this number right here, okay? So I'm going to use green for that. 24 is corresponding with that 8. And then the only other number they give me is this 18. So you can see, is that going to be this unknown or this x? Well, we don't know what the x is, but that's what we're going to figure out. So again, if you're rotating this triangle, just think about drawing this smaller triangle inside. We see that that x corresponds with the 18 feet, and that 8 feet corresponds with that 24 feet. Okay? So because we don't know what this is called yet, we're going to learn that a little bit later on. We can just say green to pink. Or you can call it the slant, maybe we can call it the slant to the height. Okay? There's a math vocabulary word. We'll talk about that it's called when it's across the right angle later on. All right. So my original figure, this is going to be my large triangle. I'll say large triangle to small triangle instead of just figure 1 to figure 2. You guys can label these however helps you out. So 24 was my green slant, and my 18 was my pink or my height of that original, that bigger triangle. And then my green slant over in the small triangle was 8 feet to x. Okay? Now hopefully, I don't know about you guys, we could do 18 times 8 divided by 24, but that's kind of some big numbers. So if we see right here, we have a between factor of change. 24 divided by 3 is 8. From left to right on the top, so I'm going to do left to right on the bottom. So 18 divided by 3 will give me my answer. So x equals 6, and don't forget your units, 6 feet. So if they tell us that they are similar triangles or similar shapes, we're going to set up a proportion to solve for that missing piece. Okay? Again, rewind this video if you need to see it again, or if you want to cross multiply and divide on these and double check to make sure that you got the same answer I did. I'm just reviewing with you guys those different strategies.